everyone, and thank you for joining our Data Zen event session today. And today I'm glad to welcome Sangeetha, Data Solution Architect at EPAM India, who will share how NVIDIA NIM can improve visibility and reliability in AI deployments. And she will discuss building an enterprise-level framework for tracking and managing AI usage. But before we start, please note that you can post all your questions in the chat during this session, and we will address them at the end of the presentation. So, Sangeetha, the floor is yours.
Thank you, Andre. Thank you. Yes. Welcome, everyone. Thank you for joining the Data Zen Community Tech Talk today. And I'm Sangeetha, Data Solution Architect with EPAM. I bring like close to 16 years of experience in data engineering, and over the years, I have worked on extensively on like ETLs, data warehousing, data lakes, and large-scale data platforms. So, and multiple data migration and modernization initiatives. I'm particularly passionate about building scalable cloud-agnostic architectures that transform the raw data into intelligent and meaningful insights. And more recently, my focus has shifted towards combining strong data foundations with generative AI in order to build intelligent and enterprise-ready solutions. So that's all about me. All right. So let me take you to the session. Yes. To set the context for the session, let me start with a simple question. How many of us trust AI responses 100% in production? Okay. Yes, no. I think it's always a mixed response, right? And now, here's the real challenge. It's not just about building AI. It's about understanding like why it behaves the way it does, right? And because in enterprise AI, one wrong response, it isn't just a bug, right? It can be more expensive. It can be a compliance issue, a financial risk, or a loss of trust with a client. Basically, the client loses trust, right, in our system, and that's exactly where observability becomes more critical, and that's where we have to learn more about like what is observability and what are the challenges that we are dealing with it, right? And that's the gap that we are trying to build, and that's in building and understanding the AI system, and that's what we call the observability challenge, right? And today we'll explore like how NVIDIA NIM and NEMO guardrails help us not just building AI systems, but also make them reliable, more traceable, and also like very safe to work with, right? And let me start with what is NIM. For all of you who are new to this, NIM stands for NVIDIA Inference Microservice, right? And you can think of it as packaging an AI model as a microservice, right? And it provides you a plug and play architecture for deploying of your pre-built AI models like Llama, Mistral, and all. And here about NIM, it basically removes the challenges in terms of your manual model optimizations and the GPU tuning that we have to do by providing some certain specific standardized API endpoints. It is all within optimized inference runtime like the TensorRT, which is the optimization engine. So getting on, like historically, like getting a large AI model, like large language model, like to run efficiently on a server, it wasn't just a matter of you just go and turn it on, right? It has a lot of parameters that we need to factor in. The model optimization part, if it wouldn't like we have to see if this model wouldn't consume too much memory or run too slowly. And coming to the GPU tuning part, we have to really write like high complex code, often in CUDA, right, to ensure the model is utilizing all the underlying the physical GPU hardware, which whether it is using it efficiently or not. No. This process, it's not only time consuming, but also expensive. We need a lot of niche skilled people to perform all this complex coding. No. And that's where here comes a solution for all of these challenges, whatever we've been facing with the traditional AI deployments. So NIM provides us standardized API endpoints and with an optimized inference runtime, right? When you see, say, optimized inference runtime, it is like instead of going and manually tuning your model, NIM uses its underlying engines like TensorRT, which automatically analyzes your model, optimizes it for the specific NVIDIA GPU on whichever it is running on, ensuring it gives you the maximum speed and in a very low latency, right? And all completely without human intervention. And that's the beauty of it, right? And all that you have to do is simply say, send an API call to the model, asking it a question, like, and it gives back you the response. It sends you back the response, right? In short, in a nutshell, NIM enables user to basically build applications using AI without you needing to be experts in all the underlying GPU hardware or machine learning or like whatever is required as an AI expert, right? You don't need all these expertise with NIM. Okay. Yeah. So looking at the slide 2, modern AI-enabled application architecture, where does this fit into our enterprise architecture, right? All right. Let's look at how this actually fits together in a real-world enterprise setup. Like, okay, let me not overwhelm you with this diagram. It's very simple. Like, it is just broken down into 3 layers, right? The first is the app layer, which sits on the top, that you see here on the top. We have our traditional application layer. This is basically a traditional application layer where our business as usual goes on. And it's basically where your users interface and like all your core app services is working on, and the integrations, they talk to your backend APIs and all, right? It is what your users are currently interacting in our in current world, right? And next comes the data layer, which is on this left side, right? So this is more about specifically about the vector database. So for those of us who are used to building, right, complex data pipelines, this is where the real magic happens. And the database, this specific vector database, it acts as your memory for your application, leading you or it feeds your specific secure enterprise context into the system. So that's where this vector database plays a big role. And then comes the model layer on your right hand side. So this model layer is basically powered by NVIDIA NIM, like, which is the brain of this entire architecture. And here you can notice this sits separately, this was planned as it to be. Okay, here in order to have the application code not to be tangled up with the AI models, so it acts as a dedicated, highly secure inference engine. So the flow is as simple as, okay, the app gets a user request, it grabs the right context, and from the vector DB, it basically grabs your context from the vector DB and hands it securely over to NIM in order to generate a response. So that's all about this architecture. Okay, moving on. So let's look at how does NIM actually change our day-to-day workflow, right? If you look at the Esplanade on the screen, that's exactly the vibe that we are going for. Like sitting at a deployment hub where the heavy lifting is all handled for you, right? That is what our expectation right now is, right? So let us split it into 3 categories. Like, okay, first comes the setup, where you do the model selection and optimization, right? And basically, you start with picking the right tool instead of hunting down on different models and struggling to make them all run efficiently. NIM gives you a curated catalog of pre-optimized models. Okay, so you pick one; it's already right tuned there to get the maximum performance out of it. Again, with the underlying hardware and engine like TensorRT, and you get a high performance engine on the go running. Right, it's out of the box. So that's with the first part, like where we do the set. And next comes the launch part, where we try to go deploy and fine tune and all these stuffs, right? And all about this is all about like how exactly you're going to get this running. We don't have to run a ton of custom code or build complex environments. NIM packages everything into a like fast, standardized container with unified APIs, right? And it basically even checks your hardware to orchestrate everything perfectly. So that's the beauty. And finally comes the operations, where operation side of it, when you look at it, like we have things like observability, traceability, scalability, right? But those of us who are used to build this robust and enterprise grade data pipelines, so the most exciting part is what happens after our deployment, right? It is always a black box, right? But here, NIM isn't a black box there, right? You get your native observability with open telemetry right away, right? You get detailed traceability to build in the traceability part, right? You have it's basically you get your detailed traceability to audit exactly what's happening with every single request. And let's say when the traffic spikes, it dynamically scales your computer. It takes the entire AI cycle and turns it into a predictable and manageable system. So that is what like how the NIM transforms our day-to-day workflow. And moving on, yeah. So looking at this wheel, right, you might be thinking like, why do I need a NIM for this? Can't I just use a hosted API or spin up my own open source model? And let's talk about like how NIM actually compares to the other options out there in the market, right? We all know the DIY method, right? Challenge, which is the do-it-yourself open source challenge, right? A lot of teams uh, try the DIY route. Okay, so they basically take the route. They grab a model, put it in a basic container, push it to production. The problem is, you spend nearly like multiple weeks just trying to build a basic logging infrastructure behind it, right? And every model, it behaves differently. It like gives you tons and tons of metrics, lots of different metrics. And look at the left side of this slide, where like NIM eliminates this completely, okay, by all giving us like versioned immutable models and with consistent telemetry. So you deploy it, and as soon as you deploy, it's like a plug and play, and your logs start flowing in immediately without you having to write even a single custom code or like doing any custom instrumentation for every single model that you incorporate, right? And on the other hand, there are like big managed APIs. They are like super easy to use, no? But I would say they are also a massive black box too, no? You send a prompt, you get a response, and but you have zero visibility on how basically the actual inference path, the journey from prompt to a response. We actually have like zero visibility or nearly minimal, right? But let's say our if the output is weird, okay, and you can't debug it with NIM, for every single request we get request level traceability and with full complete reproducibility, replayability, right? So because like every single request, we have the exact timestamp logged with the request, like metadata, and the exact inputs, and you have the ability to replay it with exact inference, because here we own the container. So that's the beauty of it, right? And think about like how we treat standard enterprise data pipelines. Let's say we would never push a complex data transformation into the production, no, without knowing exactly where the data comes from, how it was routed, and where it failed. No, AI, I think it shouldn't be different from this expectation, right? So all we have here is with the metadata tracking and the built-in governance, like as a core capabilities through Nemo guardrails. No, it brings you the same level of enterprise mindset to GenAI. That's one distinguishing factor that we have here. In a nutshell, if I have to say, DYI, it takes you long to secure, and your managed APIs don't give you enough visibilities. I think NIM sits right in the sweet spot where, like, moving us from the black box API AI to a fully observable and governed system, right? And moving on. All right. Now let's talk about the enterprise AI observability. This is the elephant in the room, I would say, which is the observability. And when we build traditional data pipelines, we expect total visibility from end to end, right? And the data lineage and so on. But with enterprise AI right now, I think we are often dealing with a complete black box, and that's the major challenge. And if you look at the left side, you will see three massive challenges that we are running into with the current AI systems. First comes the fragmented telemetry, like where our logs, metrics, and the traces are completely disconnected. And it seems like we are flying blind. And second comes the opaque infrastructure. And here we have almost zero visibility into what the underlying hardware is, specifically about the GPUs and what it's actually doing under the hood, right? And third comes the hidden logic. So here we send a prompt in, we get a response, but we just assume that the routing and the safety checks, it all worked as expected. But it's that's not the real picture here. So that's where like NVIDIA NIM comes into play. So NVIDIA NIM brings you complete observability, and that's where it's a game changer. It doesn't treat monitoring as an afterthought, like after you build and you think about how do you monitor. No, it is basically brings you observability by design right out of the box. So it cracks open that black box, giving us a deep and standardized visibility and deep visibility into every stage of the inference cycle. And here also, instead of guessing and making assumptions of what's happening into our like with our models, we finally get exactly the same level of transparency that we expect from any enterprise grade infrastructure. Yeah, moving on. So traditional AI versus the NVIDIA NIM, right? And as data people, like we expect our pipelines to be transparent and reliable. That's the most important factor, right? But with traditional AI deployments, it often feels like a gray area for us. Now let's look at how NIM is going to fix that for us, right? In terms of metrics, it provides us deep metrics. It not at the surface level. It provides us like stats, like deep kernel level visibility into exactly what the GPUs are doing. And next comes the LLM insights. Instead of just knowing that a prompt took 5 seconds to run, NIM breaks down the performance to the exact token level. And next comes the traceability. So here, instead of huge and like messy disconnected logs that we have, NIM tags each and every request with a specific trace ID, just like your standard enterprise applications. Like we have a correlation ID, like we try to trace through every single request right from the start till the end. So NIM provides you that that level of visibility with this. Okay, then comes the safety. So instead of like let's say just hopping to a model and without knowing the safety issues and all, right? And NIM uses NEMO guardrails to explicitly log and prove every single safety check is all through. So you don't seem to have vulnerabilities with this method. And basically all that we are trying to achieve here is NIM transforms, like NIM turns your unpredictable AI into the kind of reliable and highly observable system that we want to build. Yeah. Ways to deploy NIM. Yeah. With NIM, we don't have to worry really about like dependency issues or writing code and migrating it between multiple environments. Here, the deployment is completely and fully portable, right? There are three ways, like be it your local machine. You can start right on your local machine, which is GPU enabled, to experiment and test things out without even burning your cloud credits. And next comes the cloud. Your local, it can be on premise also. And next comes the cloud. It's basically cloud agnostic, be it any cloud, AWS, Azure, GCP, Oracle Cloud. No, if you're ready for an enterprise scale, you take the exact same container, you drop it into your cloud environment, and whether you are deeply integrating it with AWS services or trying to design a full agnostic architecture, the container behaves exactly the same way, and you don't need to worry about any painful migrations. Like you are all set in the happy path, right? And let's look at the NIMS managed endpoints. So here, let's say if you just want to hit an API and skip the complete infrastructure setup part completely, right? And you can use this managed endpoints for a zero ops approach. Like instead of getting stuck in the deployment loop again and again, now NIM gives you a completely smooth, predictable path from a local um, prototype all the way to your enterprise and production ready scale. So that's with the NIM managed endpoints. Yeah. And we have the NIM and NEMO framework together here. Okay. So to put all this together, it let's look at the bigger picture. It helps us to like it kind of gives us an holistic view. Now think of NIM and NEMO as two halves of a complete AI pipeline. Left hand side is the NEMO, where this is basically your workshop, I would say. You take a foundation model, you train it on your specific data and align it and optimize it so it runs fast and it stays accurate for your requirement. And it's how you build the brain of the system. So, and that's where this workshop comes into play. And on the right hand side, we have the NIM. Okay. So once the model is ready, you hand it over to NIM. NIM is your deployment engine, and it takes the fine-tuned model. It takes a fine-tuned model, puts it behind your screen, behind secure APIs, and adds the safety guardrails, basically, which helps us scrap out any PII information, and it serves it to your user. And because it's NIM, it automatically monitors everything in real time, so you can continuously improve. In short, like you say, you build a great custom model, NIM helps you run it and govern it so that we get the reliability that we are missing in the current AI systems. So that's about that's the beauty of NIM and NEMO framework together. Okay. Now let's look at an use case. Yeah, enterprise grade use case. So this is basically your LLM enterprise grade LLM building and observability framework, and with NVIDIA NIM and NEMO guardrails. So this is how this is what a fully observable and enterprise grade architecture actually looks like in your production. Let me, it's essentially like it's not overwhelming though. It's essentially like a very clean and logical pipeline that's simple to understand. Okay, let's start with the gateway and the guardrails on the left hand side. So where let's say think of it like a bouncer. Okay, so a request comes in through the API gateway, and where it gets tagged for tracking, but before it ever reaches the AI, it hits our safety proxy, and that is our NEMO guardrails here. So this NEMO guardrail, it checks the input, makes sure it's safe and compliant before we even try to spend a single cent on a GPU compute. Then comes our RAG layer. So now, once the prompt clears the safety bouncer, our NEMO guardrails, it doesn't go straight to the AI. It hits our retrieval layer first, and this is our RAG pipeline, and it does two major tasks for us here. So first, it's the catchy check that is done. Okay, we have our Redis. So where let's say whether do we have any have we answered the same question recently? If it's a yes, say hit, it just serves the cached answer immediately. It's lightning fast, and it costs you zero compute because it all retrieves it from your cache. And let's say if it's a miss, we go check our vector database, and this pulls our private company data and hands it over straight to the AI, and that's where we are giving it the exact facts to read from and retrieve. And then comes the NIM and the output rails engine, which is the engine, and this is where the exit check is also. Okay, so with that context added, it's finally it gets handed over to the inference engine, which is the NIM. So NIM does all your heavy lifting. It generates your actual response, and before the response even goes back to the user, it passes it through the NEMO guardrails again, once again. Like you can see this bidirectional. So it passes it to the NEMO guardrails once again to ensure your output is accurate, and you don't see any hallucinations. No PI data is present in your data. So all these safety checks, it once it passes through the safety check, now it has optimized inference engine through which we have the response. And next comes the nervous system of this architecture. I would say that is the nervous system, which is the observability. And here is where the magic happens. So every single step we just talked about is all throwing out lots and lots of logs and data. We have so here the open telemetry, it's like a funnel. So it all funnels right into the open telemetry collector, and from there our data splits into two parts. One is the hot path and the other is the cold path. So the hot path it goes straight to our Grafana dashboards for real-time monitoring, and the cold path, it actually goes to the tries to see if we have any sensitive PII info, and sends the exact token usage down to our database. It is all for basically your precise and automated billing and chargebacks. It is to give you a precise chargeback. And at the end, this is about closing the gaps with our in the enterprise AI, and with in terms of governance. No, governance we are here doing with guardrails, like where efficiency is with the catching and the RAG, and your accountability lies with the complete full observability and the billing part. Moving on. Okay. Now, we just walked through the journey of a prompt in our previous slides. So now I would like to highlight why we have architected these into specific isolated blocks. Now, the key thing here is decoupling. Okay, let's look at it from a security angle. So the safety proxy on the left, we intentionally isolated it, okay, from the and the NIMO guardrails from the inference engine. Think of it like, okay, think of the guardrails like your security checkpoint. Every request here is checked before it goes in, and every response is also checked before it comes out. And instead of asking the model to control itself, that is actually a classic anti-pattern. Like here we use guardrails as a filter before and after the AI. So by also making this bi-directional, we also try to stop the jailbreaks. So and filter PII before even it reaches our like expensive GPU clusters. The same thing goes for the right side also. So by keeping our RAG completely separate, completely separate from our NIM, and we scale them independently. We when let's say when we suddenly get a huge or complex searches, or like we see spikes in the searches, so in that case we can scale our vector DB without unnecessarily spinning up like more expensive GPUs. And that's where this brings in a distributed architecture. And moving on to the observability and traceability pipelines, right? And we have the hot path and cold path here. Now, like, how do we handle the vast amount of data, all that flows in through your telemetry coming from the system? We don't just dump it into one huge log file. Instead, like we saw in the architecture, we split it into two distinct pipelines, where because the engineers and the auditors, they care about two different things, or like different things. No, they don't care about the same picture. So let's say the hot path is for our SREs and ops teams. So it's completely real time. Like say if your GPU saturation spikes to 99%, or a latency suddenly jumps up, this path basically it feeds our Grafana dashboards, so that we can trigger your auto scaling immediately to keep the system healthy and live. And on the cold path, on the other hand, in this is basically a system of record what we try to preserve, and here it streams asynchronously into a data warehouse, or like a data warehouse like Snowflake. So this gives us like immutable ledger. So if let's say if there is a compliance audit 6 months from now, we have the exact trace of what happened, but more importantly, this drives our unit economics in terms of the numbers. Okay, now this slide just brings everything together. Okay, on the left we have what we see is the end-to-end flow. A request comes in, it gets secured by the guardrails, enriched through the RAG, and enriched through the RAG, and then processed by NIM in order to generate the response, right? And on the right side is what and how we try to make it enterprise ready. So here we have the full visibility and control. We track performance, security, compliance, and auditability, everything in near real time. So in simple, this is not just AI working, no. This is like this is AI. What we're trying to build is AI that is safe, which is optimized, and also fully governed in terms of like production readiness. Moving on to the strategic outcomes that it brings to us, we see here the three pillars of visibility. Visibility delivered by the LLM call wrappers. No, ultimately, like implementing this architecture isn't about the cool technology. No, it gives us like three massive strategic wins here for the business. First comes the billing visibility, where we move from completely unpredictable cloud bills to your precise chargebacks. So we know exactly which department is driving the usage and where is which business unit the cost is associated with. That's one beauty. And the other thing is the audit visibility. And so in terms of audit, we get immutable proof of governance. Immutable proof of governance. Like if compliance say compliance team comes knocking, we have the exact logs providing what that our guardrails are successfully caught and flagged, with sensitive information like PII, which is captured. And then comes the quality visibility, where we stop making assumptions. Let's say if the model is working as expected or not, by tracking exactly how often the users accept the AI suggestions and the quality of the suggestions. And that's how we can prove its real world utility and how it caters our use case. And continuously it tunes in for the accuracy. So that's about the quality visibility. Here we get control over our cost, and we have a proof established for our security, and also it is all measurable, right? And yeah, so this is an enterprise LLM observability and traceability dashboard. So basically this is a prototype that was created for enterprise LLM observability. And this is a quick snapshot of that prototype. Okay, let me zoom in. So yeah, at the top here we get a quick snapshot of like how many requests when came in, and how many tokens were used, total tokens used, the cost, the latency and all, and how many incidents were there. In the middle, we track the cost and the token assumption trends. And this basically helps us understand how our usage is growing, and where we might need optimizations. And here at the bottom, we look at the request volume, how many requests came in, and which teams are using the system more, and how basically the traffic is distributed, right? So overall, this view helps us answer three key questions that we all have. Okay, how much we are using, and how much it is costing, and how well it is performing. So those are the three questions this is able to answer us. And moving on, yeah, this is another dashboard. Yeah, so this dashboard focuses more on the quality, security, and the governance side of it, which are like very critical for the enterprise grade AI. And here we have the reg quality and the latency. And at the top, we track quality and latency trends. And This tells us exactly like how relevant our responses are and how fast the system is responding. And moving on to the security and risk side of it. On the left hand side, you see we monitor the sensitive data detection here. Things like emails, your PAN numbers, or the PAN numbers, or the internal data. This ensures basically our guardrails are working like properly as expected and as designed. No? On the right hand side, we see the approval status, and this says like how many requests were approved, how many were flagged, and you have the complete traceability. And at the bottom, I have attached here sample detailed audit log. So in order to say like every request here is fully traceable with like where it is coming from, who made the request, what was processed, the cost, the latency, and when whether it was approved or not. Like for requests like which is flagged, we bring human in the loop to judge and to pass through the request. So this dashboard basically it gives us complete confidence to say that our AI is not just working, but also it is safe and transparent, that we have complete visibility here. Together, I think these dashboards ensure like we have complete end-to-end visibility from cost and performance to quality and governance, which is current essential for all the AI which is running in production in the current world. Yes. So these are some useful links that I have added here. Like to know more about NVIDIA NIM and all that is coupled container, like whatever features we have, the inbuilt core capabilities and all. So we can refer to the NVIDIA's NIM official documentation. You have the complete list of pre-built models here. It is basically a catalog of all pre-built models. And we have like how we can use this open telemetry semantic conventions for GenAI. So these are some useful links. Yes, I think I'm done. It's time to open the floor for the Q&A.
Thank you, Sangeetha, for this detailed introduction into NVIDIA NIM. May I ask you to reset your camera, please, because your video stopped for some reason, so we can.
My visual is off.
Just turn off and turn on your camera.
Okay.
And while you're trying to reset your video, I have some questions about this technology. So NVIDIA NIM offers similar experience as we had for classic microservices, like in clouds like AWS. We're deploying some containers, then we have monitoring, scaling, billing, and it allows us to have a reproducible system, version controls, and so on and so forth. So NVIDIA NIM is almost the same system, but for AI. Is it a correct statement?
Sorry, I just missed the last piece of it. I was just trying to set my camera. Am I visible now?
Yeah, you are visible now.
Okay. If you can just come deliver the last piece of that again.
So NVIDIA NIM is a similar tool as we had for classic microservices in clouds, where we can deploy, manage, track costs, set limits. But this system allows us to work directly with LLMs. We can versioning it. We can create different containers, redeploy them whenever we need some new features or reproducible results.
Yes, you're completely right. So this is more like you plug and play and like a microservice. So
Mhm.
all the core capabilities, you get it like packaged as a microservice here with NVIDIA NIM.
Okay. So is this system allows us to use freely available models, open source models, or the models
Yes.
are limited to the ones which NVIDIA offers?
So it is, you can use it in conjunction like with any model that you want to, or you can NVIDIA NIM also provides you a list of like it has already a lot of the models where it has a catalog of pre-built models, be it your open source AIs, your Mistrals, your Llamas, whatever model you can think of. You can go look at the NVIDIA official website. You have all the list of models there, and you can also like work on it with in conjunction with the Hugging Face and all. So it's completely flexible.
I see. Thank you. And you also mentioned that there is a way how we can train models inside NVIDIA NIM. What does it mean train? Should we train it from a scratch, or how it can be accomplished? Should we take a
So
pre-trained model and then add some reg or something else?
yes, it's basically the same kind of usual flow that we have, right? Where we saw like in a specific slide when if I can just go back and to that slide. Yeah, this is where. So this is where your NIM, we have the pre-trained models in NIM, like Llama, Mistral, and all, which is already trained with large data. So we can even fine tune it with NVIDIA NEMO. Like you had your domain specific knowledge, say like let's say it's a finance or a healthcare domain. So in order to like improve like your accuracy and relevance to the responses, no, and you can also do prompt tuning with this Nemo. This is kind of like more faster and cheaper, I would say. Like we don't need to reinvent the wheel or like reinvent the model. We are just going and doing some customizations on top of it. We always don't train models from zero. We already we try to like adapt to like existing pre-trained models, and align it to our business context. So that is what NVIDIA Nemo helps us here. We need not
Mhm.
train it from the scratch. We just have to like add some flavor to it of your business.
Yeah, I see. So we need to set a role correctly and provide the correct context to the model. This is what
Yes,
is
yes.
training about
And that
here.
context is done through your vector DBs and all. No? Your rack comes into picture.
Hmm. And what about prompt libraries? Can we store our effective prompts somewhere in this system and reuse it when we deploying new AI agents as a microservices?
So yeah, in terms of storing your prompts, definitely we have like databases like what I've used in this enterprise. We like let me show you that. Go back here. Here I have used Redis, okay, in order to store like whatever the prompts that we are currently giving. It is basically kind of an asset that we have, the prompts that we are entering now. So you have your config systems like either you can do it with some templates. You can store it in your DBs or store it in your S3 or like any specific config service, and then you integrate it with your AI frameworks. Like let's say let's take tools like your LangChain or the Llama Index, no, where it supports you that prompt templates. So how this fits in, basically these prompt templates, it can be stored somewhere centrally, and then you go have your AI agent go and pick them dynamically, no, then you can it becomes kind of like more reusable.
Mm-hmm.
Did that answer your question?
Yeah, thank you. And another question, how this system can help save costs? Like, can it fine-tune models, choose another LLMs a bit cheaper than currently using to reduce costs? How it works? Can you explain in a few words?
Comparing between models, right?
Yeah, we have a production, say we have a production system. There are some containers already running. And as I understood, the system can help to understand that those containers can be, say, reduced or switched to a more cheaper model for such tasks because the logs shows that we are using too expensive model for such simple tasks. Is it
Okay.
achievable using NVIDIA NIM?
Okay. So in terms of choosing the right model, again, we that's where we had that observability metrics in place, right? So we go look at the metrics, like whether whatever the responses it has provided us, and it's like more evident from the dashboards, the observability metrics that it is being providing, right? You have that open telemetry with the dashboard, so you see like which model is used. You have the complete grain level of information there. So you see like how much token it is consumed, and what is the latency, what is the cost. And let's say there you go and identify, okay, the model is not responding or as expected to my use case. So can I go switch back, or to a different model, or use a smaller cheaper model, like let's say instead of llama 70b, can I go for a mistral, or like can I fine tune the model, or can I like have some caching. So all these things you can decide, like looking at the dashboard and the kind of metrics that you have inbuilt. So you swap the model, it is all just like behind the scenes, like where there is no changes required, is just the API call which is change which is required.
I see. Thank you. And we have one question more from our attendees. Does NIM only designed for LLMs, or it can support any kind of a model, like logistic regressions, trees, and so on?
Can you come back on that?
So originally, NVIDIA NIM is designed to use LLMs. But can we replace LLM model with another kind of model, not LLM, like logistic regression model or decision trees, and build our enterprise system using all those blocks, but with not with AI, but with
Yeah, you
another
can
kind of models?
yeah, it is basically NIM is like more efficient with all your deep learning models, no? Especially it is not only with the generative AI models like your LLMs. It is also your regression, the kind of models that you're seeing, your traditional ML models. So anything like it is basically just adding you an optimized flavor on top of it. It gives you an optimized inference for all your models that you're choosing. It can be like the core, the model which NIM is providing you, or you can integrate. Uh, let's say you have a computer vision model. No, you can very well integrate it, and yeah, it is not like very specific.
I see. So it's a platform. It allows to use various type of models, and we
Yes,
can
yes,
build
yes.
anything we need to achieve our goals. Thank you.
It's
And
like built like mostly for all the heavy AI workloads, and for enterprise grade workloads.
And what about quality gates? So you've shown us that there are many ways how to enable telemetry on this system, and it measures tokens, costs, everything. But how we can implement quality gates here to measure how responses are good or bad.
Okay, quality gates. Yeah. So that's where we were speaking about the guardrails. So quality gates, I would say it is more about the guardrails, the safety proxy checks that we were seeing here, right? Like if you see in the current slide also, we have that like whenever you get an response, it again goes back to our like Nemo guardrail servers, and where it validates like the for the form clarity, and it tries to check if basically the correct context is retrieved from your RAG. So we have the RAG here. Your response again goes to the your response from the NIM again goes to the safety proxy. This is our quality gate here.
I see. So it's a kind of a workflow of several agents. One agent is generating a response, another agent is validating it, and if quality gate is passed, so the response will be sent to a user, right?
Yeah, it is more like here combined by evaluating your metrics and your feedback loops. So wherever if you look at the dashboard, can recollect the dashboard which I shared, right? Like we were flagging PI information also there. Like in case some information, PI information is flagged, it doesn't allow it beyond that guardrail. That is where we have guardrails. We bring human in the loop there and to see and assess and then pass through that.
I see. Thank you. And one more question. In what form the model is deployed passed to NIM? Is it infrastructure as a code, or how it implemented in NVIDIA?
So it is okay. NIM is basically it is implemented as a microservice, a plug and play architecture.
So do we need some repository with deployment scripts?
No, all that is already taken care of by NIM. It is like you don't need to like have containers, then like you have to deploy models on top of it and all. No, it is already packaged. It is giving you you don't need to go harvest and all. No, it is giving you the fruit in the hand, like right, you get it from the shop. So that's how you just make a standard API call, and that's where you it's a plug and play. You start using it right away without worrying about any thing behind the scene, the infrastructure part.
And if you develop your own ML model, the Docker container which must follow with Docker container which must follow certain rules, how would NIM understand and know what to optimize there? So it's not a pre-built container, you've developed your own, and how NIM can scan it and understand what needs to be deployed and how it should work optimally in the whole infrastructure.
Okay, so it is not only like see kind of like you're always open to have your have NIM as a plug and play. You, it is not necessarily you don't need to have kind of vendor lock-ins. This is again going through the DIY method, like what we were discussing. No, you're trying to like build a container, and top of it you try to deploy things. So that is also like possible, but all that is like you get you are trying to have your optimized inference with NIM here. So all that, if you want to take the DIY route, it is all custom, and we have to have like build scripts and like basically get the essence out of NIM's inference service.
And how to pass GUI container? Should we deploy it somehow to NVIDIA?
Sorry, can you come again?
How to deploy your container which you developed on your own to this system? Do we need to publish it somewhere?
Okay, how to, okay, let me go back to that slide. Okay. Okay, this is where we were discussing about the how do we deploy NIM, right? So here, like let's say we have a container, and we have a it should be all the base image should be basically GPU enabled, and on top of it, like NIM has the model with all the CUDA in place. So the model and the inference code, using like fast API, you have the endpoints like NIM managed endpoints. So it basically it doesn't expect a raw script. It is a ready to use kind of microservice.
Mhm. Okay, so to deploy your own model, you need to expose this model as an API and then pass this
Yes.
API endpoint to
You
the
you have to
NVIDIA
go
NIM.
through that API contract route, wherein you have to check that it has to go through the standard request, and or like an JSON, and we have to like ensure or factor in things like, okay, the token based inputs and all. Like when we do it like more like a DIY, like we have to take care of a lot of things,
Mhm.
like
Okay.
the data taggings also, no, like we make a container, you have to make your container behave like it is a NIM native model. You have to push that image to a registry, container registry.
Mhm. I see. Thank you. We run out of time. There are a few more questions. I will connect you with the attendees who asked them, and you can proceed in the chat. Thank you, Sangeetha. Thank you all who joined this session today. And don't forget to say thank you to our speaker by pressing like on the page and giving our speaker a page. And stay tuned to get more content like that. We will have more and more events this year, so please stay tuned. And thank you all. Thank you, Sangeetha.
Thank you for this great opportunity. Thank you.
Bye bye.
Bye.